Hello viewers, welcome to Senior College Mathematics. In this series of teachings, we have college geometry, plane and circle. Lesson 21, circle theorems, part 3. In this part, we want to consider cyclic quadrilaterals. Before then, let us explain the meaning of a quadrilateral. A quadrilateral is any plane shape with 4 sides and 4 angles. For example, or for instance, you have a square, you have rectangle, you have kite, you have rhombus, you have parallelogram, you have trapezium. All these plane shapes have 4 sides and 4 angles. The sum of the interior angles of any given quadrilateral is 360 degrees. Now, a quadrilateral inscribed in a circle such that the 4 vertices touch 4 different points on the circumference of the circle is called cyclic quadrilateral. When you have a quadrilateral that is inscribed, drawn in a circle such that the 4 vertices touch 4 different points on the circumference of the circle, such a figure is called cyclic quadrilateral. We have 3 of such figures below. You have it that the quadrilateral ABCD, EFGH, and PQRS above are cyclic quadrilaterals. Now look at this. We have PQRS is a quadrilateral that is inscribed into the circle. It becomes a cyclic quadrilateral. Theorem 4. The opposite angles of a cyclic quadrilateral are supplementary, or angles in opposite segments are supplementary. Note, the sum of supplementary angles is 180 degrees. Now you have this cyclic quadrilateral. So given a cyclic quadrilateral ABED with the center O, to prove angle BAD, this angle, plus angle BED, this angle, both angles are opposite and their sum is equal to 180 degrees. This is what we want to prove in Theorem 4. Construction: join B and D to the center O such that OB is equal to OD, that is equal radii. Proof: the procedures to be adopted. Now, the obtuse angle BOD from Theorem 1, this obtuse angle is equal to 2 times angle BAD. That is, angle at center is equal to 2 times angle at circumference. Also, the reflex angle, this other angle BOD, is equal to 2 times angle BED. Same reason, angle at center is equal to 2 times angle at circumference. Since angle BAD is opposite angle ED, we can decide to add both sides of these two equations. When you add, you have it in this form. And you should note that the sum of the obtuse angle and the reflex angle is equal to 360 degrees. So you replace this side with 360 degrees and equate it to what you have here, and this is the result. So from here you can factor out 2 in this form, and when you divide both sides by 2, you have angle BAD plus angle BED is equal to 180 degrees as required. Theorem 5. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Now, we want to use this figure to prove this theorem. Given a cyclic quadrilateral PQRS with side PS produced to T. To prove angle PQR, this interior angle is equal to angle RST, this exterior angle. Proof. From here, you have it that S1 plus Y is equal to 180 degrees. That is Theorem 4. Opposite angles of a cyclic quadrilateral are supplementary. Again, you have it that S2 plus Y is equal to 180 degrees angles on a straight line. Now, in both equations, the right hand sides are equal, 180, 180. By implication, the other two sides are also equal. Now, we are interested in showing that S1 is equal to S2. So let's transfer this plus Y to the other side. You have it in this form. And plus Y minus Y is equal to 0. So S1 is equal to S2. That is, angle PQR is equal to angle RST as required. Examples number 95. P, Q, R, S, and T are points on the circumference of a circle. Angle QPT is equal to 146 degrees. If QT is equal to QS, find angle TQS, angle TQS, and QRS. So we have to get this angle and this angle. All right. In this figure, we have two cyclic quadrilaterals, P, Q, S, T, then T, Q, R, S. If you are looking at P, Q, R, S, T, that figure is not a cyclic quadrilateral because you have 5 sides and 5 angles. All right. So for us to get this angle, we need this angle, and with the help of this angle. So considering the cyclic quad P, Q, S, and T, you have it that angle QPT plus angle QST, that is this angle plus this angle, is equal to 180 degrees. You have the reason. Angle QPT is 146 degrees plus angle QST equal to 180 degrees. Therefore, angle QST becomes 180 degrees minus 146 degrees, and that is 34 degrees. Now, look at triangle TQS. We're told that QT is equal to QS. By that reason, the base angles are equal. So, in triangle TQS, QT is equal to QS. Therefore, the base angles, angle QTS, is equal to angle QST. You have the reason. Thus, angle QTS is equal to 34 degrees because QST is 34. QTS becomes 34 as well. In that triangle, if you add the three angles, the sum is equal to 180 degrees. You replace two of the known angles with what they stand for. You have this result. To get angle TQS, you have to transfer this value to the right hand side. You have it in this form. And angle TQS becomes 112 degrees. Next thing is to get this angle. To get this angle, we can consider quadrilateral QTROS. This angle and this angle, their sum is equal to 180 degrees. You have the reason. It follows that 34 degrees for QTS plus angle QROS is equal to 180 degrees. Therefore, angle QROS is equal to 180 degrees minus 34 degrees, and that is 146 degrees. Example 96. In the diagram below, ABCD is a circle center O. AE and CE are straight lines which intersect at E. If angle BEA is equal to 52 degrees and angle BAE equal to 18 degrees, find the value of the reflex angle AOC. This is the reflex angle, and to get the reflex angle, the obtuse angle is needed. To get the obtuse angle, this angle at circumference is needed. And to get this angle at circumference, you have to consider triangle ABE. In that triangle, this angle ABC is exterior to the two opposite interior angles. By that, angle ABC is equal to angle EBA plus angle BAE. You have the reason why it is so. It follows that angle ABC is equal to 52 degrees plus 18 degrees, and that is 70 degrees. All right? Now, what I have here is obtaining this angle. You obtain this angle. What I said earlier is also applicable. But what I have here now, after obtaining this angle, here you get this angle so that you can get the reflex angle. All right? All right. So angle ABC plus angle ADC is equal to 180 degrees. You have the reason. Therefore, 70 degrees plus angle ADC is equal to 180 degrees. It follows that angle ADC is equal to 180 degrees minus 70 degrees, and that is 110 degrees. So we know this angle at circumference. So the reflex angle AOC is equal to 2 times this angle at circumference. So reflex angle AOC is equal to 2 times angle ADC. So the reflex angle becomes 2 times 110 degrees, and that is 220 degrees. Like I said earlier, if you get this angle first, if you get the obtuse angle, it's still going to be 140 degrees. It will be like that because here is 70. So this obtuse angle becomes 2 times 70, 140 degrees. So if you add this obtuse angle to the reflex angle, the sum is 360 degrees. When you subtract, you will have 220 degrees as well. So any of the approaches will give you the same result. Example 97. In the figure below, PQRS is a cyclic quadrilateral. If PQT and SRT are straight lines, find the value of angle S. That is this angle. Now this angle plus this angle, their sum is equal to 180. So this angle is needed. To get it, we have to consider triangle PST. The sum of the angles in that triangle is equal to 180 degrees. You have it in this form and this result. To get angle PST, you have to transfer 103 degrees to the right hand side, and after subtraction, angle PST is equal to 77 degrees. Now, considering quadrilateral PQRS, angle PSR plus angle PQR, this angle plus this angle, the sum is equal to 180 degrees. You have the reason. So 77 degrees plus angle PQR is equal to 180 degrees. To get angle PQR, which is angle S, you have to transfer 77 degrees to the right hand side. It becomes 180 degrees minus 77 degrees, and that is 103 degrees as the value of angle S. Find the marked angles in the following figures. You have example 98. You have to find angle S, Y, and Z. Solution: 79 degrees plus S, the sum is equal to 180. Sum of angles on a straight line. So S becomes 180 degrees minus 79 degrees equal to 101 degrees. Now, S is 101 degrees, Z is interior, 79 is exterior. Both angles are equal. You have the reason. Now, if you add Y and 69 degrees, the sum is equal to 180 degrees. You have the reason why it is so. Therefore, Y is equal to 180 degrees minus 69 degrees, and that is 111 degrees. Therefore, S is equal to 101 degrees, Y is equal to 111 degrees, Z is equal to 79 degrees. Example 99. In this figure, we are to find the value of S. To do that, we need this angle so that in triangle BCE, if you add the three angles, the sum is equal to 180 degrees. Now, in quadrilateral ABCD, this angle is exterior to the interior angle, and both angles are equal. So, angle BCE is 2s degrees. In that triangle, if you add the three angles, the sum is equal to 180 degrees. You have it in this form, and 3s is equal to 180 degrees minus 60 degrees. 3s becomes 120 degrees, and s is 120 degrees divided by 3, and that is 40 degrees. Example 100. In the figure below, angle PQRO is equal to 80 degrees and SROT equal to 20 degrees. What size is angle PSRO? That is this angle. Now, don't make the mistake of adding this angle to this angle and say that the sum is 180 degrees, because PSRQ is not a cyclic quadrilateral. This point here is not touching the circumference. So we have to consider triangle ROSS, so that you need this angle. Once you get this angle plus 20 is equal to this exterior angle. So we have to consider quadrilateral PQROS, so that this angle plus 80 degrees is equal to 180 degrees. You have it in this form, and angle S is equal to 180 degrees minus 80 degrees, and that is 100 degrees. In triangle ROSS, angle PSRO is equal to angle R plus angle S. You have the reason, and angle PSRO becomes 20 degrees plus 100 degrees, and that is 120 degrees. End of lesson 21. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess Him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.